Hello 345 students. Ryan here to take you through the solubility and extraction experiment. Let's start with the point of this lab. This experiment will introduce you to liquid-liquid extraction, which is a technique you can use to separate two or more compounds based on their solubilities. Here's how it works. Let's say you had an aqueous solution of ethanol that was contaminated with benzene and you wanted to get the benzene out of it. To do this, you could mix your solution together with some organic solvent. Since benzene is more soluble in organic solvents than it is in water, it would migrate to the organic solvent, or organic phase, and therefore remove itself from the water, which we also call the aqueous phase. However, since ethanol is more soluble in water, it would stay behind in the aqueous phase. This experiment will be a variation on this theme. Instead of using liquid-liquid extraction to separate two different compounds from each other, you will use it to determine how benzoic acid's protonation state affects its solubility. See, when benzoic acid reacts with a strong base like sodium hydroxide, it loses a proton, and, in doing so, it goes from being neutral to having a net negative charge. Over the course of doing this experiment, you will evaluate how this affects benzoic acid's solubility in aqueous or organic solvent. Now let's go over your procedure. As you may have guessed, a big part of this is going to involve mixing aqueous and organic solvents together. However, you're not going to do this in just any old container. Instead, you're going to mix them in one of these here pieces of glassware, a separatory funnel. These funnels have a valve at the bottom you can use to drain off the lower layer and leave the upper one behind. This will let you separate the two layers as well as any solutes that are dissolved in them. Note that the lower layer isn't necessarily the aqueous one. This depends on the density of the organic solvent you use. If that solvent has a higher density than water, then the organic solvent will be on bottom. Before you begin, you're going to want to dismantle your separatory funnel so you can thoroughly clean it. Wash the inside with a little glass cleaner, then rinse the glass cleaner off with some water, followed by DI water. Do the same with the valve insert to make sure it's clean too. After you've got your sep funnel reassembled, you can use an iron ring to hold it up. The next thing you'll need to do is make a solution of benzoic acid. Do this by weighing out between 200 and 300 milligrams of benzoic acid and dissolve the acid in about 20 milliliters of diethyl ether. After all the acid has dissolved, add the solution to your separatory funnel. Oh, and make sure the funnel's valve is closed before you add the solution, with the handle perpendicular to the funnel's axis. If you don't, this might happen. Next, add 20 ml of hydrochloric acid solution and put the separatory funnel's cap on. To help the extraction along, you're going to have to shake your flask's contents. To start, make sure you've got your fingers on the cap to hold it on, give the flask a small shake, then point its spout into the hood and open the valve to vent it. This is to relieve the pressure that builds up during shaking. After the first time you vent it, the pressure buildups won't be as bad, so you can shake it a little longer and more vigorously before you vent it again, which you want to do every few seconds or so. After you've shaken and vented the flask about 5 times, take its cap off and let it sit in a ring long enough for the organic and aqueous layers to separate. As soon as they have, drain the lower layer off into a small Erlenmeyer flask. Next, add 20 milliliters of sodium hydroxide solution to your flask and again shake and vent it 5 times. Then drain the aqueous layer into a separate Erlenmeyer flask. When you're done with that, pour the ether out through the top into a beaker and place the beaker in your hood. While the ether in your organic extract volatilizes, you can neutralize your acid and base extracts. Neutralize your acid extract by adding about 5 milliliters of sodium hydroxide solution to it Check the pH with litmus paper, and if it's not neutralized, add another 5 mL of hydroxide and check the pH again. Do this until its pH is neutral. As you probably noticed, we used a Pasteur pipette to add the sodium hydroxide. These tend to pick up about 1 milliliter with each use, so you can add 5 pipettes worth to your extract when you do this part. You'll neutralize the base extract the same way, except you'll add hydrochloric acid to it instead of sodium hydroxide. And finally, take a good look at your 3 extracts and record what you see in your lab notes. This info will help you determine which of the 3 extracts your benzoic acid ended up in. When you're done with everything, make sure to dispose of your aqueous waste in the aqueous waste container and liquid organic waste in the organic waste container. Solids can go in the solid waste container. Depending on the semester you take this course, you may perform the follow-up experiment organic separation techniques in another lab period. This experiment is similar to the one I just described, but instead of exploring the solubility of benzoic acid in different conditions, you will use liquid-liquid extraction to separate a mixture of 3 compounds. The secret to doing this is to first identify the functional groups in these compounds, then determine how these groups' protonation states will be affected by acidic and basic conditions, and then predict how the compound's protonation states will affect their solubilities in aqueous and organic solvents.